Hello Phoenix people and welcome to a new and exciting Chaos Phoenix tutorial. Today I'm going to show you how you can make something like this. Today I want to show you how you can light an object gradually on fire and in the meantime modulate the fire opacity using the V-Ray distance texture or using the Phoenix grid texture to get the speed of our simulation and modulate the fire according to it, so we can see only the fastest parts of the fire or the slowest parts. But this is way too much talking, so let's dig in. First things first, we'll need to light an object on fire. So I will fire up Chaos Cosmos and then you can pick whatever object that you like. And I've scrolled through the library and I already know what I'm searching for. So we have this puzzle arc, which is really nice and cool. And what I need to do now is I'm going to go in the modify panel and then I'm going to import this as a mesh. This way we can use it for our simulation. And in here it imported the mesh. So I will delete the proxy because we won't need it anymore. And then we'll just rename this to puzzle arc. Okay, so right now it's kind of small, so let's scale it up, way up, something like this maybe. Okay, and then if we just want to light it on fire, we can, of course, as you know, I'm a big fan of the fire preset in the toolbar, so I can add the fire preset, just start simulating, and immediately our object is on fire. But in this case, what we want to do is light it up on fire gradually. So I want the fire to start in here from the bottom left, then to slowly start engulfing our object on fire. So how we can do that? For such cases, we can use the fuel. And first, we need to cover our object in fuel. So I will delete the caches from the simulation because we don't need them anymore. And this is where our fire source came up from our simulation. So what we need to do is let's go and disable the temperature because we don't need it for this source. For now, let's disable the smoke and let's enable the fuel. And now, if I start my simulation, you'll see that nothing happens. So this is it because we need to do some tweaks. Let's go in here and under the preview rollout over here, I will disable the GPU shaded preview so that we can see the fuel. And then I will go in my output rollout and enable the grid fuel channel. Now, if I start my simulation, we'll be able to see our fuel. But right now, it's really explosive. Nothing what we want. We just want the fuel to cover our object and stay there. So in order to do that, we need to brush the fuel inside of our object. So what I'm going to do is go in my Phoenix source and let's set it to volume brush mode. But this will warn me that only non-solid emitters can be used. And would I like to convert my emitter to non-solid? So let's say yes for now. And if I start my simulation right now, you'll see that now we have some fuel and it almost stays in one place and it's not that explosive, but again, it's going all over the place. And this is because our fire preset is creating a turbulence node. For this scene, we won't need it anymore, so I will delete it. And now, if I start my simulation again, we can see that the fuel stays in one place. Okay, but still, this converted our object to a non-solid. This means that its surface won't interact with the simulation. But for this case, I would like my object to be solid and still be able to brush some fuel. So what I'm going to do is I'm going to select my source and remove my object, and then let's make it a solid obstacle. And now, in order to be able to emit fuel, we're going to create some particles. So I will delete the caches. And what we can do is I can press 6 on the keyboard. So this will fire up the particle view for particle flow. And let's drag a standard flow so that it has all the predefined operators. And in here, I will select the speed, the rotation, and the shape. And I will delete them because I don't need them. And we need to replace the position icon with position object. So I will scroll a bit in here and I will drag over my position icon so that we can see this red line. This means that the operator will be replaced. And in here, using the position object, I can pick an object. So now let's pick our puzzle. And for the bird operator, I will set the emit stop to 0 and will increase the amount to 10,000, for example. And now let's make the particles red so that we can see them. And we have some particles. So then we can go in our source and click over the particle flow source. And then we can start emitting and we have some fuel. But what we need to do is scroll down a bit to the bottom of the Phoenix source settings and we can adjust the particle shape. Currently, by default, it's using 1 voxel. So each particle will be 1 voxel large. But this is not enough in our case. And if I change my grid resolution, the particle size will change as well. So in this case, we want to use a constant size for our particles. So let's use a custom size and let's set it to something 0.04 because I think this will be a bit better. And I think we need way more particles because right now we have way too few. So what I can do is let's go in here and let's spawn. Oh, I did only 1,000 particles. So let's do 100,000. Yes. Now it's more like it. But as you can see, when I start my simulation, it's a bit slow. Now we have a lot more fuel, but as you can see, a few seconds passed and we're still on frame 2. That's because particle flow is still single-threaded and it's very slow. So what we can do instead, if you have access to tyFlow, we can use tyFlow instead, which will be way, way faster. So let's see how we can do the exact same setup in tyFlow. In case you don't have tyFlow, you can use particle flow. It's perfectly free. It comes up directly inside of 3ds Max. The downside is that it's a bit slow. So I will select all of these particle flow nodes because we don't need them in here. I will delete the simulation caches, and let's go and create a tyFlow node. Then I'll open the editor and let's recreate the same setup. We need a bird and position object. Then for the position object, I will pick my puzzle, and then let's set the end frame to 0, and let's set our particles total count to 100,000. Then, because we have quite a lot of particles, we can change the display amount to 1%, for example. And let's make them kind of bluish. I like blue. And maybe what we can do is let's change the default shading to clay. Okay, so now we can see them a lot better. And what I need to do is just go in the tyFlow settings, enable the particle interface. This way, Phoenix will treat tyFlow as particles. And let's add our tyFlow node. And now, if we start our simulation, we can see how much faster it is compared to what we had previously. It's already on frame 16, 17, and we have our fuel. Okay, so far so good. We have some fuel, but we need to ignite it. So in order to ignite it, we need some temperature. So let's duplicate our source and make it a copy. And actually, in order to be able to distinguish them, I can call this temperature, and I will select this one and I will rename it to fuel. When you have a bit more sources, it's really a great idea to color code them like this and change the names so that you can know which is which. And for the second one, for the temperature, let's change the mode to surface force, and let's enable the temperature and disable the fuel. This way, we'll enable temperature only from the surface of the object. And now we need an emitter. So let's go and create a sphere. So something like this, for example, something nice and small that will be emitting temperature. So set it over here, and let's pick the sphere over here and start the simulation. And let's see how this goes. Okay, we can see that it starts burning, but it's not spreading and it's not activating our fuel. So let's stop our simulation. I will go under my preview and enable the GPU preview so that we can see what's going on a bit better. And now let's go under the fuel rollout. I'll expand it so that we can work with it a bit easier, and I will enable the burning. And now our temperature will be able to ignite our fuel. And if we give it a few more frames, we'll see that our fire spreads over our object and everything is on fire. Okay, so far so good. We have some fire, but it's kind a bit more aggressive than we need. So let's stop the simulation and see what we can do. In this case, we have smoke amount of 1, and this is how much smoke will be produced during the process of burning. In our case, we don't need any smoke for this simulation, so I will set this to 0. And the next thing that I want to change is how fast our fire expands and how explosive it looks. In this case, I'd like to reduce my propagation. And for every parameter in here, you can just select it and you can see a tooltip what it does. In this case, what the propagation does is controls the speed of the expansion of the fire and the smoke that is generated by the burning fuel. In this case, we want it to be slower, so let's try a value of 1 and see how this looks. Okay, now it looks a bit better, but we can see a lot of artifacts. And that's because our grid resolution is really rough. As you can see, our voxels are pretty large. So what I can do now is, let's stop my simulation. I will go under the grid rollout and I'll increase my grid resolution. Now let's start the simulation again and see how this looks. Okay, I will stop it at this point, and now it starts to shaping up pretty nice. Okay, looking much better, but I want to do a few more tweaks to my simulation. So I will increase my scene scale a bit so that my fire will start to rise a bit more and move a tiny bit slower, just behaving a bit more like a larger fire. And in here you can see that my fire will be treated like 6 by 6 by 4 meters in height, so that's quite large. And the next thing that I want to do is just increase a bit my fuel depletion, and this is the rate at which the fuel will be burnt out. So let's increase this to 2 and start our simulation again. Okay, our sim is done and it looks quite nice, but as we can see, our simulation finished right before our object is fully on fire. So what we can do is I can go in my time configuration and give it a few more frames. And because I don't want to start my simulation from the start, I just wanted to continue from where it left off, I can use the restore simulation Phoenix toolbar button. So in order to use it, just go to the last simulation frame that you have and where you want to continue the simulation, and just restore the simulation. As you noticed, it went back to frame 90. This is our last backup frame, and our simulation will continue from there. And in case if you want to change your backup simulation frames, you can go under the output rollout. In here we have a backup interval. In this case, every 15 frames we'll have a backup frame that we can restore our simulation from. And as you can see, now our object is fully on fire. Okay, so far so good. So now let's get to the good stuff and do some rendering. Now let me go to frame something like this, maybe. I think this one looks nice. And let's do a quick render using V-Ray. Do a quick render and let's see how it looks. Okay, not bad, but I think we can improve it a lot. As you can see in here, the fire around the object doesn't look that nice. And in reality, if you've noticed, the fire is a bit more transparent near the source of emission and a lot more opaque towards the top of the fire. So let's see how we can do that. What we can do is go under the rendering route and let's go and open the volumetric options and open the fire settings. In here, we can control all of the render settings for our fire. We can change the color, the intensity, but in this case, what we're interested in is this option in here. We want to modulate the fire opacity using a texture. In this case, let's pick the multiply opacity by texture, and when I choose this option, I'll be able to select a map that will modify it. Let's click over the map, and in this case, I want to use V-Ray distance texture. So let's search for V-Ray distance. Or distance, yeah, okay. I needed to type it without the dash. So distance texture, okay. And let's open the material editor and I will drag the distance texture in here. Now, if we do a render, we can see that nothing happens. Nothing happens because we need to tell the distance texture which object to use. So let me stop the rendering and let's keep this frame as a reference. Then let's go under our distance and move this a bit out of the way and pick our puzzle. Now, if I do a test render, now we can see that it started doing something. And if we compare this to our previous render, we can see that. Sure, let me stop the rendering because recording and rendering at the same time is a bit heavy on my PC. But you can see that on the left, we have the full non-modulated part, and on the right, our distance texture starts to modify the look of our fire. And in here, if we go to the distance texture settings, we have a few parameters that we can play around with. So we have a distance, we have far color, and near color. So where our texture is near the object, it will be black, and where it's away from our object will be white. And then this distance controls how far we need to be. So if I increase this a lot, let's render it out. You can see that only the far parts from our object are opaque and the near ones are super transparent. And essentially what happens is we take this texture, we multiply it with our fire, and where our fire is near the object, it gets transparent, and when it's far away, it gets more opaque. So let's pick something like 20. I think should look quite decent. Yeah. And we need to give it a bit more time to clear the noise up. But as you can see, now it's starting to look a lot better. And by the way, while we're waiting for this to clear up a bit, what we can do is modify our look a bit in the V-Ray frame buffer. So what I'm going to do is I will enable the filmic tone map because it makes every file look so much better. And for the type, I will pick Ampas. And if I turn this off and back on, you can see that our file looks much better with it. Okay, and now if we compare before and after, you can see that we get this nice and gradual fall off. But as you can see, in this case, we have a bit more render time, but in this, I let it render longer, so there is that as well. And let's see how we can modify this even more. So for the distance texture, what you can do is, let's set it back to 10 and do a render. And let's keep this as a reference like this. And then what I can do is I can go and color correct this distance texture. So I will do a color correction. Let's plug the distance texture in here, plug the color correction in here, and I can give our distance texture a bit of contrast. So let's try something like 70, for example, and see how this looks. Okay. Kinda nice. Okay, and if I stop and save this as a reference, we can see this is without the contrast, this is with the contrast. So with the contrast, it makes the blacker parts even blacker, so that some of the detail in here is lost. And it gives this nice and gradual fall off. Okay, so far so good. The next thing that I want to show you is that you can use the Phoenix grid texture. And the grid texture, it reads the simulation data from our simulation grid, and then we can use this for our rendering. So let's go and under maps, Phoenix FD, and let's create a grid texture. Then we need to tell it to use a simulator. So I will go in here and pick our simulator. Then we need to specify which channel we want to use. So in this case, I want to use the speed. And in order to be able to use the speed channel, just go and make sure that in the output rollout for the simulation, you have the velocity exported. So the speed is derived from the velocity. So you can either export the grid speed rollout or the grid velocity channel, and you'll be able to use it directly in the grid texture. So when I pick the speed, then we can use this grid texture to modulate the fire opacity. So let's plug it in here in our slot and let's do a test render. and see how this looks. Okay, why does it look this way? Because our speed is way too high. If I go under my simulation rollout, we can see that our velocity is in the range from almost 0 to 1,000. And this is way too high for our opacity. So what we need to do is we need to remap our grid texture in order to fit the 0 to 1 range, for example. So we can do that by using the rescale grid channel. I can click the button in here, and from this window I can specify a minimum and a maximum value for our speed. And let's rescale this to a current frame. Let's close this, and we can see that what this did is it changed our color scale to 0.01. And now if I do a render, we can see that we have something like this. And essentially what happens now is our grid texture will read the speed of our simulation, and it will make the fastest part white and the slowest parts of our simulation black. In this case, we get this really nice and detailed look of our fire. And in case if you want to bump up the intensity, you can of course modify the color scale. So let's type something like 0.04, for example. And now it starts to look a bit more like it. And we get a bit more of our detail. And the really cool thing is that we can combine both approaches, and we can use the distance and the speed and multiply them in order to get even better result. So let's set this to 0.02, for example, and I'm going to go under maps, under V-Ray, and let's create a V-Ray comp texture. Then I will connect my color correction texture and my grid texture as a source B. Then we need to change our operator. Instead of add, let's multiply them. Then I will go and plug this in our slot over here for the opacity texture. And let's do a render and see how this looks. I think we'll need to give it a bit more firepower. So what we can do is, let's go under here. Maybe I like distance this way, so let's maybe bump this back to 4 and see how this looks. Okay, quite nice. And let's give it a few moments to clear up. And now we can see that we get this nice fall of our fire, and we get really great results using this technique. Using the grid texture, you can use the simulation data and shade the fastest parts to be visible or the slowest parts to be visible. Of course, you can add as many color corrections after the texture, so you can reverse a result, you can multiply it, you can make it stronger, you can make it weaker. And using the distance texture, you can control the opacity of the fire based on a distance to a certain object. And last but not least, if we want to convert this object to a bit more, this fire to a bit more magical one, what we can do instead is let's go under our color corrections and I can pick a hue and saturation. Then I can change the hue to something like blue, something like this. I really like blue, as I said before. And let's enable the lens effects. And this way we can add some glow. And I will increase the size a lot, increase the intensity. And let's increase the bloom like so. And let's lower the threshold like so, so that we can get a bit more of this glow. And we can even bump up the intensity. I think that's a bit overboard. But as you can see, with a few tweaks, we made our fire look a bit more magical. And let's save this one. And in case we want to get back to the old one, we can just disable the lens effects, disable the hue and saturation, and save this one as well. And as you can see, we get two totally different looks with just a few simple tweaks. Okay, and as a final touch that would improve slightly the visual aspect of our scene, but it has nothing to do with our simulation, is I want to add some reflections on the ground over here. So let's see what we can do. I will close this over here and this one as well. So what we can do is go in here and create a plane like this, and I'll make it, let's make it big. This way we'll know that nothing will be missing. Maybe let's make it even, make it like this. Yeah. Okay, and then let's go and create a new material. So I will make a V-Ray material. Then what we need to do is make it black but reflective. So I will set the diffuse to pure black and the reflection to pure white. Then let's rename this material to ground and assign the material to the selection. And let's do a render and see how this looks. Okay, very nice. And finally, the final touch that I would like to do is go in here and enable the motion blur for my rendering. And this is what we get in the end. And final thing before I want to say goodbye is a thing that I just remembered and I want to mention. So let's stop the rendering, and in our case, we just created a plane, but Phoenix doesn't like single phase geometry that much. So if you want to run your simulation again after you have created this ground plane for the rendering, what you want to do, in case you don't want it to interact with it, you can just exclude it in here in the scene interaction. So I can pick it and just add it in my scene interaction rollout, and this will exclude it from our simulation, and the simulation won't interact at all with it. In case if you want to the plane to interact with your simulation but still be used for the rendering, what you can do is just select the plane, go in here, add a shell modifier, and extrude it a bit. I think 1 meter is a bit too extreme, but something like 0.05 or something like this, move it a bit down, and this way it won't produce any problems for our simulation, and it will still look just as good in the rendering. So again, here is the final result. Thanks a lot for watching, guys. I hope you really enjoyed this tutorial. We saw how we can use the fire opacity modulation by texture in order to use the distance texture or the grid texture to read the speed channel. And we also covered how we can use fuel and particle source in order to gradually light our object on fire. Okay, guys, thank you very much for watching. I hope you enjoyed this tutorial. If you liked it, press the like button. If you want to see more, subscribe to my channel if you haven't already subscribed. Let me know what you want to see next in the comments. Thanks, guys, and I will see you in the next one. Bye-bye.